All right, there we go. All right, number 17. So number 17 says, base their answers to question 17 to 19. Mhm. Base their answers to 17 to 19 on the cross section below, which shows the bedrock structure of a portion of the lithosphere. Letters A through D represents locations in the lithosphere. All right. So I see, right? You see all these different things. Okay. Number 17, identify one of the most abundant minerals in the metamorphic rock at location A. Calcite. How do we get calcite? So we're gonna go to reference tables, page 7, right? Yes. So let me erase all this. All right. So yeah, so if you see the symbol for location A is marble. It's the same thing, right? It has the same symbol. So then from there, all we do, looking at page 7, we look at marble and we look at composition. We look at composition. Remember, for a rock, when you're dealing with rocks, the composition talks about the minerals it's made up of. That's why you could have said calcite and or dolomite or dolomite. All right. All right, number 18. We on the packet number 5, 18. So it says, explain why the type of rock changes between locations B and C. So from B to C, right? From B to C, we see how the rock is changing, right? It goes from slate to phyllite to schist and gneiss. All right. How can we find out why this type of rock is changing between B and C? This is packet number 5, number 18 we on. Well, these rocks, slate, phyllite, schist, and gneiss, right? Where do we see those? Yep, they're all metamorphic rocks. And what rock is B? What rock is B? Not siltstone. Let's look at the map symbol. Shale. So I'm gonna look. Let's go to page 7, right? And I know at rock B, I see shale, right? And then as I head from B to C, I see it literally in this order. You start with slate as 1. You start as phyllite as 2. Schist is 3. And gneiss is 4. What else is happening as you're going from slate to phyllite to schist and gneiss? What else is changing? According to page 7 of the reference tables. The heat and pressure. What's happened to the heat and pressure? It's increasing. And that's your answer for number 18. As you're heading from rock B to C, right? The heat and pressure is increasing. And you started with shale, and look what it says on page 7, right? When you start off with shale, look in the comments right here. Once shale goes through low grade metamorphism, it turns into slate. And if you continue to increase the heat and pressure, it turns into phyllite. You increase it even more, it turns to schist. And then you increase it even more, it turns into gneiss. So number 18, the heat and pressure increase. All right, number 19. So 19 says, identify the grain size of the metamorphic rock at location D. So what rock is D? What rock is D? What does it say? Hornsfeld. Where do I find this metamorphic rock? Page 7. Let's turn to page 7. Let me see. Sorry, 19. There we go. Right? And all I'm going to do is I'm going to go to Hornsfeld, right? And how do I find out the grain size? What do I do next? Yep. You go to where it says grain size and you look to the left, and the answer is fine, right? So, yeah, I have to look. Hold on. And so, yeah, so it says fine, and so that's going to be your correct answer. The grain size is fine. So, in the world of science, where we talk about grain sizes, coarse means large crystals, right? Fine means small crystals. So if you see a rock that looks like it has glitter on it, those are actual very small mineral crystals. All right. So number 20 says, base their answers to question 20 to 22 on the cross section below, which shows rock units A through E that have not been overturned. Number 20 says, state the diameter of a particle normally found in rock unit B. Here's the statement, by the way, but it's 3 copies. Yeah. All right. What is rock B? All right. What is rock B? Where can I find out where rock B is? All right, Abigail, you are correct. All right. We gotta go to reference tables and we gotta look at page 7. Page 7. All right. So we go to page 7. We go to page 7 and I see it says the sandstone, right? I see it says sandstone because you gotta look at the map symbol. The map symbol for sandstone looks very similar to right here. That's how I know that this is sandstone. All right. Now it says state the diameter of a particle normally found in rock unit B. Then from there, all I gotta do is go to sandstone. Here we go. And I gotta go to grain size. And so it says state the diameter anywhere from 0.006 to zero point zero 0.02 centimeters. That's the diameter of the particles that's in sandstone. All right. Five. Here we go. 21 says identify one metamorphic rock that may be found along the boundary between rocks units C and E. Identify one metamorphic rock that may be found along the boundary between rocks units C and E. So let's take a look at rocks units C and E. And I'm glad for this question because there are some confusion, okay? So they're talking about C is right here, right? E is here. They're talking about this boundary right here that I circled, right here. There is a different type of rock where these hatches are than where the outside of the hatches are. There is an actual different type of rock where these hatches are. Anybody know what are the steps for me to find out exactly what this rock is right here where these hatches are? The key, explain to me. All right, that is an important part. These hashes right here, they represent contact metamorphism. That means that it has to be a rock that has experienced contact metamorphism, right? Now, these hashes, what rock is it landing on for this question? What rock? Limes. How do I know that this is limestone? Yup, page 7 on the reference tables. Look at the map symbol. If it looks like bricks, it's limestone. Look on page 7, right? And right, sorry, let me erase all this stuff. Right here is bricks, which means that it's limestone. So that means that I have to look for a metamorphic rock that when contact metamorphism occurs on limestone, it changes to this rock. What metamorphic rock started off as limestone and went through contact metamorphism? What rock? Marble. You see how it says right here, metamorphism of limestone? So marble is one answer. What is another answer you could have said besides marble? Besides marble. And I'm looking on the Zoom. Yeah, Abigail, you're right. You could have also said Hornsfeld. The reason why is because it tells you various rocks changed by heat from nearby magma lava. So marble is an example, and Hornsfeld. And here's what's most important: it has to go through contact metamorphism. Marble, it tells you, can either marble can be created from regional or contact. So that's why it could be any of these two. All right. All right. All right, boom. All right. All right, so just work with me. All right. So number 22, it says identify two processes that form rock unit A from sediment. All right. People in the Zoom, I know you're thinking why I'm repeating myself. Just bear with me. I forgot to press record. All right. All right. So I gotta look at rock unit A. All right. And what is rock unit A? Conglomerate. All right. How do I know that it's conglomerate? Page 7 of the reference tables. Page 7 of the reference tables. Where we at? Ooh, hold on. Let me scroll. Here we go. No, this is the wrong one. Here we go. It was right here. There we go. The map symbol conglomerate, right? They tell me that it is a sedimentary rock. So rock unit A is a sedimentary rock because the map symbol right here is conglomerate. All right. And I know it's a classic sedimentary rock. What page of the reference tables can I find those two processes that make classic sedimentary rocks? It is page 6. All right. And I look at the arrow that's directly pointing to sedimentary rock, and it is compaction and cementation. So that is a process that sedimentary rocks go through. That is correct. All right. That is the end. No, yeah. If you wanted to include deposition and burial in that, that is fine as well too. If you wanted to include that in your as part of your answers, that is fine as well too. All right. Thank you guys for joining so much. Make sure that you share, like, and subscribe. And I'll see you next time. Take care, people. All right. So number 1 says the table below lists some information about the minerals graphite and diamond. Some properties of diamond are different from those of graphite because diamond is blank. All right. So when I'm looking, they want to emphasize the properties of diamond that are different. Why are some of these properties of diamond are different from graphite, right? One of the main ones that I see here is hardness. There's a clear difference in hardness, right, between graphite and diamond. And the reason for that is because the atoms are arranged differently. So based on how the atoms are arranged, they're responsible for a number of different properties between minerals. That's why the correct answer is choice one. All right. It can be because they have a different composition, because here the composition is the same. The age does not play a role with some of those different properties, right? And the fact that the diamond forms larger crystals, that deals with the formation, where diamond is formed compared to graphite, not the reason why they have different properties. All right. Let's see. Number two says Basin answers the question 2 and 3 on the data table and on your knowledge of earth science. The table provides information about 4 minerals A through D. The diagram below represents a sample of mineral A. Mineral A is most likely what? Right? Well, what page we going to look at for number two? What page? Page 16. We're looking at page 16. All right. So page 16. Hello, test. Okay. Page 16 says right here. Yeah, go, we clear it. All right. So page 16, the properties of common minerals. And so what we're going to do is we're actually going to look at the characteristics for A. So A has a cleavage breakage, hardness of 2.5, a metallic luster, and the color is silver. So when I go to page 16 of the reference tables, I'm looking for exactly that. I'm looking for a metallic luster, right? So it's going to be in this category. I'm looking for a hardness of 2.5, all right? I'm looking for a cleavage breakage, the check marks cleavage, and I see the color silver, right? Metallic silver. And your correct answer is galena. That's why the correct answer is choice two. The answer is choice two. Number 3 says, which mineral can scratch A, B, and C, but cannot scratch D? All right. So if I can scratch A, B, and C, I need to have a hardness of whatever it's equal to, right? So 2.5, 2.5, and 3. At least a hardness of whatever it's equal to. So I definitely need to have a hardness of at least 3. All right. And then it says you cannot scratch D. So I need to find a hardness that is equal to 3, but less than 6.5. Right? So it has to be less than 6.5. So equal to 3, but less than 6.5. So when I look between talc, quartz, dolomite, and selenite gypsum, when you look on page 16 of the reference tables, page 16, you're looking at the hardness of all 4 of those, and the correct answer ends up being dolomite. Out of all 4 of those options, dolomite is the one that has a hardness of between 3, right? It's 3 or greater than, and it's less than 6.5. That's why dolomite is the correct answer for choice number 3. Number 4 says the graph below shows the hardness of 4 minerals. Which mineral is hard enough to scratch calcite, but is not hard enough to scratch amphibole? All right. So I got to go to page 16 to find out what is the hardness of calcite. All right. We got it. All right. So when I go to page 16, I'm going to look for calcite. Let's look for calcite. And what's the hardness of calcite? What do we get? It's 3. So it has to be a mineral that can scratch calcite, right, of 3. And it says it can't scratch. If we look back on your packet, I'm flipping, so make sure you have your packet in front of you. It cannot scratch amphibole, right? So amphibole, where is amphibole? Right here. It has a hardness of 5.5. So I'm looking for a mineral that is either 3 or greater, but less than 5.5. And the only mineral that is 3 or greater, but less than 5.5 is fluorite, because it has a hardness of 4. So it fits in between that range, right, of a hardness of 3 to 5.5. So fluorite is the correct answer. All right, number 5. Number 5 says, which 2 properties are most useful in distinguishing between galena and highlight? All right. So key thing, we have to see which properties are most useful in distinguishing. So if I see galena and highlight, I have to pick which 2 properties are different, right? So let's go to page 16, and we're going to find galena, and we're going to find highlight. All right. Let me zoom out a little bit. So I found highlight and galena. Where you at? Here we go, galena. All right. So when I'm looking, I'm going to compare some of these properties. So number 1, what are the 2 things that are different? Well, their hardness is the same, 2.5. So that's not going to be able to let me know the difference between them. Their breakage is the same. They both have cleavage breakage. So that means I can't use breakage, right? So, however, they both have a different luster. One is metallic and highlight is non-metallic. So luster is one thing that's different between them. And the other thing that's different is color. Galena is metallic silver and highlight is colorless to white. So therefore, color and luster are these 2 properties that would be able to determine the difference between them. That's why the correct answer is choice 2. Number 6. Number 6 says, which processes lead directly to the formation of igneous rock? So there are 2 processes that has to be done to create an igneous rock. What page of the reference tables am I looking at? I'm going to look at page 6 and look in the rock cycle section. All right. One thing that I notice, if I go from any rock, if I'm starting from a sedimentary rock, or even I'm starting from a metamorphic rock, there are 2 processes that you always have to go through, right? Melting to turn it into magma, right? And then solidification. So those 2 processes always have to go through melting and solidification. That's why the correct answer is choice 4. All right. Number 7, it says the data table below lists characteristics of rock A, B, C, and D. Which rock is most likely phyllite? So this rock phyllite, where can I find this rock? On page 7 of the reference tables. All right. Okay, wait, hold on, because I'm recording. So yeah. So page, sorry. So number 7, I look for phyllite, and when I scroll down, sorry. All right. And I'm looking at the characteristics of phyllite. So phyllite has a foliated texture. Its grain size is either fine to medium, and the composition, so phyllite has garnet, amphibole, feldspar, quartz, and mica. When I look at all these characteristics, right? Foliated, fine to medium, quartz, amphibole, garnet, the correct answer is choice D. Correct answer is choice D. All right, number 8. Number 8 says most of the sediment that is compacted in later form shale bedrock is blank. All right, so when I'm looking at the rock shale, and I need to see what most of the sediment that is compacted in shale. So I'm going to go to page 7 of the reference tables, right? Why? Because when I look at shale, right? Shale has sediments that are compacted because shale is a sedimentary rock. And when you look under grain size to see what sediments are compacted in. And most of the sediments are clay. So that's why the correct answer is clay. All right, number 9. So base your answers to question 9 and 10 on the diagram below, which represents a rock composed of cemented pebbles and sand. So number 9 says, this rock should be classified as blank. So the fact that the background information says it's a rock composed of cemented pebbles and sand, that lets me know that it cannot be an igneous rock, right? It cannot be an igneous rock because we know that igneous rocks are created right from melting and solidification of magma or lava, all right? So cementation, right, is a process of a sedimentary rock. If we look on page 6, of the reference tables, we'll see right here one of the processes that creates a sedimentary rock, cementation. So I know that this rock is a sedimentary rock. How do I know if it's clastic or if it's bioclastic? Bioclastic rock lets me know that it has to have some sort of organism remains on it, right? So, like for example, a fossil is a bioclastic rock, right? If it has plant remains on it, any sort of living organic remain that is in the rock will make it a bioclastic rock. So the fact that it's just pebbles and sand lets me know that it's only choice 4. A clastic sedimentary rock. Number 10, which change would most likely occur if this rock became buried deep within Earth's crust and was subjected to intense heat and pressure, but did not melt? All right. So the fact that if this rock was buried deep in Earth's crust and it was subjected to intense heat and pressure, but did not melt, right? That lets me know that it would be a metamorphic rock, right? If it did not melt and it was exposed to heat or pressure, page 6 of the rock cycle lets me know that rocks that are exposed to intense heat or pressure can become a metamorphic rock. All right. So automatically I can cross out 2 and 3. Reason why is because a plutonic rock, right? A plutonic rock, look on page 6. on page 6, you see the word plutonic right here in the igneous rocks identification category. So a plutonic rock is an intrusive igneous rock. And it cannot be that because it did not go through melting. It did not melt and then cool down. All right. It also can be 3 because of the fact that it has a felsic, composition. Rocks that have a felsic composition is also on page 6, and it would be, once again, an igneous rock. All right. And we know that because it did not melt, right? Because it did not melt, the density of sand and pebbles would not decrease. It would not change, right? It did not change its state of matter. So that's why the correct answer is choice 4, right? And as a matter of fact, where it says the pebbles would be distorted, right? It actually shows on page 7 what type of rock actually this is. If you take a look, it tells you right here, pebbles may be distorted or stretched, right? Which is a metaconglomerate rock, which would be, once again, a metamorphic rock. All right, number 11. It says basic answers to questions 11 through 13 on the table and photograph below and on your knowledge of earth science. The table shows the approximate mineral percentage composition of an igneous rock. The photograph shows its true scale crystal sizes in this igneous rock. All right. So it says number 11 says identify 2 elements that are commonly found in all 3 minerals in the data table. So I'm going to go to page 16 and I'm going to look at these 3 minerals. And so the point is that I know that minerals are made up of elements, right? So I'm going to identify 2 elements that are in all 3 of these minerals. So when I go to page 16 of the reference table, here we go. Let me clear all this out. And I'm going to look, right? And you should have your packet with you. So the 3 minerals that I see is, sorry, nope, not this one. 3 minerals that I see, plagiocase feldspar, which is right here, amphibole, and biotite or biotite mica. Now, what I'm going to do is I'm going to look in the composition section, right? Because the composition section is going to tell me all of the elements that are in this mineral. And I have to find which elements are in all 3 of these. All right, so when I zoom in, take a look. So in all 3 of these, I see O for oxygen. O, O, and O. So oxygen is 1. I see Al, Al, and Al. That's aluminum. And in all 3, I also see Si, Si, and Si. So I see O, Si, and Al. And what is it? Aluminum, Al, O, oxygen, Si, silicon. So 2 out of these 3, if you wrote down any of these 3, you would be correct. Silicon, oxygen, and aluminum would be your answer. Number 12, name this igneous rock, right? So it has to have these 3 minerals, only these 3 minerals, and even look at the percentage, right? 55% plagiocase feldspar. Biotite, that means it has a little bit of biotite, and it has to have at least a third or less than a third of it has to be amphibole. What page do I look for? right, for this igneous rock, I'm looking at page 6 of the reference tables. And when I look at page 6 of the reference tables, right, I see more than half plagioclase feldspar, biotite, and amphibole all fit in this category right here, right? So that means my answer has to be either diorite, andesite, or vesicular andesite, all right? Now, it has to be one of these answers, so how do I simplify to get the right one? When I'm looking at these diagrams, you see these black things right here, right? These and even these gray pieces right here. These are all mineral crystals. And they gave us this scale, right? Because some of these mineral crystals are 1 centimeter long, right? And 1 centimeter is actually equal to 10 millimeters. It's something to keep in mind. 1 centimeter is actually equal to 10 millimeters. But the point is that these crystals are actually pretty big, right? If you have crystals that are 0.7 or 0.8 of a centimeter, or actually 1 centimeter, right? That means that these crystals are big, right? They're visible, all right? So that means I'm going to look, and when I go to page 6 of the reference tables, large crystals means they have a coarse texture. And that's why the correct answer is going to be diorite, because it has a large crystals, right? Coarse texture means that it's large crystals. And you look at the crystal size, 1 millimeter to 10 millimeter, right? 10 millimeters is equal to 1 centimeter. 1 millimeter is equal to 0.1 centimeter. And so we saw crystals that fit in that size. That's why the correct answer is diorite. All right, number 13. It says identify 2 processes that form this rock, right? We just identified that this rock is an igneous rock, all right? And so all igneous rocks go through 2 processes. And let's look at our rock cycle. Let's go to page 6, and I'm going to circle them. All igneous rocks, they have gone through the process of melting to turn into magma, right? Or lava, and solidification. And those are your 2 processes, melting and solidification. Number 14, it says basic answers to questions 14 through 16 on the diagrams of Bowen's reaction series below, which shows a sequence in which minerals crystallize as magma cools and forms different types of igneous rocks from the same magma. The arrow for each mineral represents the relative temperature range at which the minerals crystallize. According to Bowen's reaction series, how is the chemical composition of plagioclase feldspar found in basaltic rock different from the chemical composition of plagioclase feldspar? Sorry, hold on. Found in granitic rock, right? How is a chemical composition, right? How is it different? Okay, between basaltic rock and granitic rock. Well, what's the difference? All right. Look at basaltic rock. Look at the plagioclase feldspar, and what does it say? It is more calcium rich. And that is your answer. The plagioclase found in basaltic rock. How is it different from the plagioclase in granitic rock? It tells you right here. It's more calcium rich. That's your answer. They told you according to the Bowman reaction series. That means according to this diagram, that means that my answer has to be according to this diagram. And that is your answer. All right, number 15. So number 15 says, describe the temperature conditions shown in Bowman's reaction series that explain why olivine and quartz are not usually found in the same igneous rock type. All right. It says describe the temperature conditions. We got to describe the temperature conditions that explain why olivine and quartz are not usually found in the same igneous rock. Well, let's look at olivine. Why is it that olivine and quartz are not found in the same igneous rock, right? Well, let's take a look. What is the temperature condition of olivine? The temperature condition is that olivine has high temperature. It forms in high temperature. What is the temperature condition of quartz? Is that it has low temperature. And that's your answer. Olivine has high temperature. That's the condition. It's created in high temperature. And olivine, quartz, it crystallizes in low temperature. And that is literally your answer for number 15. All right, number 16. So number 16 says, identify one similarity and one difference between the igneous rocks andesite and diorite, okay? Now, in this case, they're not telling us to find the similarity or difference based on the Bowman's reaction series, based on this diagram. So that means I can actually find my answer on the reference tables. So let me look at andesite and let me look at diorite, all right? So what page of the reference tables do we look at? We're looking at page 6 of the reference tables. So if I take a look, I see andesite is here. I see diorite is here. What are some of the similarities? So when we look at the similarities, what is similar? Their color is the same. Similar color because they're in the same category. So color is the same. Their density is the same. They're similar in density. And their composition are similar. Any one of those would be a similarity. All right? Any one of those. Now, when we look at differences, let's take a look at differences. Well, one of the differences is their environment of formation. That's one difference. Andesite is an extrusive rock, which means it was created on the surface. Diorite is an intrusive rock, which means it was created underground, right? Underground, underneath the surface of the earth. Another difference, crystal size, right? Andesite, less than 1 millimeter. Diorite, between 1 millimeter to 10 millimeters. So their crystal size is different. And last, their texture is different. Fine texture for andesite, coarse texture, right, which once again describes the size of the crystals, for diorite. So any of these differences will be fine. If you mention environment of formation, crystal size, and texture. Similarity, color, density, composition, right? Even the minerals that they're made up of is similar. All right, so make sure to like, share, and subscribe. That's the end. If you're looking for the other problems, 17 to 22, look at the beginning of this video. Have a wonderful, blessed day.